Hello and welcome to the C programming lecture on looping statements. What are looping statements? In C, there's a variety of ways of creating something that we call loops. Basically, we have the ability to jump back to the top of a piece of code or a block of code and iterate over that many times. So just like exactly what we're saying, we're looping over something. The following is a list of the looping statements that are available in C. We have the while loop, for loop, and do while loop. Now, there's other ways of accomplishing loops, but these are the primary ways that we are going to concern ourselves with. So here's an example of the while loop. In C, a while loop has parentheses that contain a Boolean expression. And when that expression evaluates to true, it will continue to evaluate whatever block of code is inside of this scope or the only line after. Now keep in mind that this can, once this evaluates to false, it will stop this particular loop. Now here's an example of a while loop. We have a variable x, which is assigned to the value 0. And we are iterating over in our while loop. We have a block of code here. We're printing out the current x value, and then we're taking x and incrementing it by 1. So you can see here that this is continuing to execute in this first block. And when we hit the value 10, it will break out. And you can see that here that's the reason why it's not printing out 10 and instead 9, because this is not equal to 10. Is not less than 10. So we do another while loop here, and you can see that I'm using the shorthand plus plus operator, and we can get the same output using the plus plus operator, and we do not need a scope here. Now, that being said, if you do not have a scope, you need to make sure whatever your condition is that it will eventually evaluate to false, or else you will be stuck in something called an infinite loop. Okay, let's go over the for loop. So the for loop has, just like the while loop, a parentheses here, a pair of parentheses, but it's actually segmented into 3 different sections. We have the initialization section, the Boolean expression section, and then this increment, decrement, or assignment, whatever you want to call it here, this section. Now, each of these sections are separated by semicolons, and usually you'll see a block of code, a scope created underneath it. And just like the for loop, just like the while loop, the Boolean expression here will continue it once it's continuing to evaluate to true. It will keep executing this code underneath, and when it hits false, then it will stop. And typically you'll use these in conjunction with each other in order to create an expression here that will eventually evaluate to false. That being said, it doesn't necessarily have to work that way. It's just a convenient way of looping. Here's an example of a for loop. We have our beginning output, and then we have, just like you see here, our initial for loop. So we're creating a variable x. That x variable is going to be assigned to the value 0. Typically, it's best to create it equal to 0, but I'm just showing in this case, it's just automatically defaulting to 0. So then what we're doing is we're just incrementing and executing this code. Our Boolean expression is just like the while loop. We're making sure our x value is less than 10. So the first loop completes, and then we're doing the exact same thing, except we're using shorthand notation, and we're not using a block, a scope here. So the next thing that we're going over is the do while loop. So the do while loop works a little bit differently than the other 2 looping statements. Basically, in the do while loop, it will execute the scope of code at least once. So you're guaranteed to at least execute the do section, this scope created here, at least once before it hits the Boolean expression. So this is useful in cases where you may need to ask for some type of input from the user and then indicate whether or not you need to go back and process something else. So here's an example of a do while loop. We see that we, just like our other examples, we have x equals 0, it executes once, and then we just keep dumping out just like before. And again, it's not, this scope here is not necessarily required. We can do something like on line 13. However, for a do while loop, it's probably best, just because it can get a little confusing as to what's going on, to always create these scopes. So again, in C, we have 3 different main looping statements. We have our while, for, and do while. Each of these statements works slightly different, but really it's, at the end of the day, it's basically the same result. So however you want to accomplish a task, you can basically do it using one of the 3. So just don't get caught up in which one you need to choose. Just pick one. Some people like to use different looping statements given different scenarios, but like I said, at the end of the day, they basically do the same thing. Okay, let's go ahead and get some examples going with our looping statements. So the first thing I'm going to do is I'm going to create my file, main.c, and just like we do in every other video, we're just going to get this boilerplate code set up here. We're going to say include h, and then we've gone over this enough times to where you should be fairly comfortable with just setting up this initial portion and compiling your code. And really, it's a good habit to have when you're first starting out. Just like I always said throughout this entire course, is, you know, just getting this boilerplate code up and running, especially on a new system, is pretty important to just test out whether or not you have things configured properly. All right, cool. So let's go ahead and go over the while loop. So we're going to go ahead and make a int x. We're going to assign that to 0. Let's make a while loop here. And we're just going to go ahead and say, let's just do while x is less than 100. Let's just print out, let's add some complexity. Let's say for every x that is divisible by 10, let's just output that number. %d and x. Right, so it's going to loop through. So what we should see is anything that is evenly divisible. So basically, so we have 100, you know, like, so for instance, we should have here, let's use the number 100. Let's actually do this. We'll say 10 mod 10 is 0, so we should see 10, 20 as well. So all of those. So we actually need to swap this guy. All of the multiples of 10. Oh, yep. So here's a perfect example of an infinite loop. So now what we forgot to do was actually increment x. So you could see that we just keep getting 0, 0, 0, 0, 0, 0. And that's just because 0 mod this is a condition. We can actually make this more complicated. We could say and x does not equal 0. You know, for instance, and just to remain consistent, let's go ahead and put these in braces here, or in parentheses, so that way we know our conditions. And if we wanted to, we could format this slightly different like this, but let's just keep them on the same line. I have a feeling that this looks a little bit better. All right, so we're recompiling, we're gonna run, and we can see that we also, you see it hanging now, like the program, just like before we had the 0, 0, 0, 0, now it's just hanging. The reason why it's hanging is because we're not incrementing x, just like I was saying before. So we need to increment x, and we can do that just by simply at the end of our loop statement, just add a x++. So now when we recompile the program and run, we get exactly what we expect. Okay, cool. So that was, this is a great example of using a looping statement while just having our also like internal selection statement inside of there. So let's go ahead and use, let's try a for loop. So with a for loop, let's go ahead and just create a new variable. Typically you'll see things like int I equals 0 while I is less than, I don't know, let's say 100 again. So let's do basically the same logic here. So we can actually, let's change it up a bit. Let's say while we have a number that's divisible by 11. Okay, so while we have a number that's divisible by 11, we want to output that number. So let's go ahead and let's just grab this guy, have that print statement, and then we'll just do basically the same thing as above, except swap it out for 11. And we also want to have our edge case here. Now here, let's do it a different way actually. Let's set this to 1 so that way we know that we'll never run into this second condition up here. Okay, let's go ahead and compile this program, run it, and we see that what's occurring here is that x mod 11. So let's think about this here. So we should actually be seeing output. Now let me try to recompile the program. Okay, so x is less than or equal to, it should print that out. X mod 11 equals 0, so I would assume 11 should be printed out. Okay, yes, so this is a perfect example of why you shouldn't reuse variable names. So this is actually I, because our ith variable is our internal variable to this loop. X is actually defined outside of here, so we accidentally put X. And the reason is because most of the examples I've been reusing the variables. But that's all right. That was what was going on here. I was using I. I had I actually initialized here when I should have, and inside this loop I was using X when it should have been I. So now this is the results that we expect, 11, 12, yeah, so on and so forth, things that are divisible by 11. So now what we'll do is we'll have a do while loop example, and I just want to show you that this is just going to be a very concrete example, and we'll have 2 do while loop statements. So this executes at least once. So we'll have this statement, and then we'll have this statement. Let's say let's do this. Let's think of a bool value, and let's just set it to true. Let's just say L for loop while this is true, and then we'll just inside of here, let's reuse X, set it to 100. Let's set it to 0 actually, and then we'll say X++, and basically we're like, we actually don't need this bool, but let's just do it this way because it's, I feel like it's a little bit more interesting. What we're going to do is basically say this. We're going to say, you know, if X is equal to 100, let's just make L equal to false. So that we basically break out a loop, and we can also put this statement inside of here. This is just another way of showing you how you could do it. There's no right or wrong way, technically. So for this bool, first things we need to do is add that, and then we also need to include the bool header. And now we can recompile and run. Okay. So you can see that this executed at least once. Let's also print something out here and say exiting out of loop. And again, these are not necessarily practical examples. This is just a way for you to kind of wrap your head around how some of these things work. Yeah, so for instance, like this will execute at least once. We can see that through this case here, right? Because we have a false statement. So we see that this executed at least once and then broke out of the loop and then went down to this loop. And this is not even that long. So like, let's make it a little bit longer so that maybe we notice the pause. Yeah, we don't. We'd probably have to make it a lot larger than this. And even then, yeah, there we go. So we'll notice that this kind of takes a while to run through, and then maybe eventually this will exit out, but it may take kind of a long time. Or we might actually overflow and this is too large. So we're going to go ahead and exit out of that. And let's just make it like 1,000 or something. GC may not see. And what we can do is we could just actually flood the output. Why not? With with some stuff like this. And let's do this. Let's do a /r here, and then maybe a x value. Let's see what this looks like. Again, we're just messing around, kind of figuring stuff out here. Okay, so the exiting out of the loop. If x equals 1000, we exit out of the loop, else we're printing out some stuff here. So let's see. Let's recompile. Let's see, get that out. So exiting out of the loop should actually only execute when this is equal to 1000. So do while is going to execute this. So this return statement, I believe, is probably what's happening, is that this writes so fast that that we can't see it actually doing its thing. There we go. So that's kind of weird. You probably didn't catch that, but let's try again. GC may not see. So basically what the /r is, and you can see here, it's just like rewriting this over and over and over and over. So, and you can see here, actually, we had some type of weird artifact of the output. So what we'll do is we'll just leave it at 100. And I guess what we can say is, okay, so this will overwrite. Let's do this. Let's make a new line. Let's see what this does. Yeah, so there we go. This it actually printed this one out, but like I said before, if the larger we grow this, like you actually see it like incrementing and stuff. Let's see if, yeah, like that. So kind of neat. It's just one more time, so that way you can see it kind of like do its thing, and then we'll eventually see it just hit that value, and you can see that it looks like it actually did some type of overflow here or something. So we'll just leave it at this and recompile. And there we go. Okay. So anyways, these are looping statements. Definitely type these out and get familiar with them. Also, there's other things that you can do. You can actually make looping statements inside of looping statements. Inside of, like, you just keep doing this. But, you know, think about this and think about the consequences of this. If you have, you know, if in this loop you're iterating, let's say 100 times, and then inside of this one you're like, so you're looping over 100 times, and this one you're looping over 100 times 100, and then this one is 100 times 100 times 100. You could see how crazy this can get. You know, yeah. So play around with it. You can also look at different like things called runtimes to kind of get an idea. But yeah, definitely type these out, mess around with them, see what you can do with them. And yeah, thanks for watching.